Hi there and welcome to another video from Faraz Maths. It's Mr. Faraz Hassan here, and in this video we are learning indices with algebraic expressions 1. So previously on Faraz Maths we did these 9 rules. So let's revise these 9 rules. So the first one here is that power of n, a to the power of n. So it means a times a times a to the power of n. Or if I take any number, suppose 3. And let's take power 2 on it. So 3 power 2 means 3 times 3. A power 0, any number to the power of 0 will be equal to 1, or you can say 3 power 0, or any number to the power of 0 equals to 1. A power 1 means A. In the similar way, let's say 3 to the power of 1 is 3. Or you can also say like this, 4 power 1 is A to the power of negative n. It means 1 over A to the power of positive n. Or if I have a number over there like 3 to the power of negative 2, it will look like this, 1 over 3 square. And 1 over 3 square means 1 over 9. A 1 over n. A, and in the power we have 1 over n. So that's mean it's a radical or nth root of A. Suppose if you have 27 and then you have 1 over 3 in the power. So that's a cube root of 27. So whatever number in the denominator, it will come here at this place. And then you have to make a radical. A to the power of m over n. So that will look like this, nth root of A, and the whole power would be m. So suppose if you have 27 and that is 2 over 3 in the power. So it will look like this, cube root of 27 and to the power of 2. Cube root of 27 is, and to the power of 2, the whole answer would become what? 9. Because cube root of 27 is 3 and 3 square is 9. The multiplication rule, when bases are same, we add the powers, a to the power of n plus m. Suppose if you have 3 power 2 and 3 power 5, then it will be 3, 2 plus 5, which is 7. And in divide, when bases are same, we have to subtract the powers. So it will look like this, a n minus m. Then you have 3 to divide by 3 to the power of 5. And that will give you 3 negative 3. 3 to the power of. And in the last one, we have a n to the power of m. A n m. And then 3. Suppose if I have a number 3 over there and it is square there, power outside. So you have to just multiply the power of powers. So 2 5s are 10, so that would be 3 to the power of 10. So we have revised all of these rules. So now we can implement it in our questions. So let's start with the questions. The first question here is write in index form. So it's quite easy. You can do it in this way, index form. It means that you have to add the powers. So each 2 has power 1 on it. So we can add the powers, and how many 2's we have? 1, 2, 3, 4, 5. So that is 2 to the power of 5. This one would be 1, 2, 3, 4, 5. So this is going to be x to the power of 5. So don't forget to add their powers, and you cannot write it like this 5x. If you write 5x, that is wrong. Okay? We are not adding x, we are multiplying x. So you have to add the powers in the multiplication. The next one, here 2 will remain as it is, and then times x by x by x by x by x, 1, 2, 3, 4, 5. So 2x raised to the power of 5. And the last one, 2x times 2x times 2x times 2x times 2x. So that would be 2x whole power 5. And if you simplify it further, it would be like this, 32, because 2 to the power of 5 means 2 times 2 times 2 times 2. 2 2s are 4, 4 2s are 8, 8 2s are 16, 16 2s are 32. 32, and this power will come at x also, 32x raised to the power of 5. Now you have to be careful that 2x raised to the power of 5, it is not equivalent to 2x whole bracket and then 5 on it. So they both are not equivalent, they both are different from each other. Okay, coming to the next, write it in the index form. So here we have x times x times x, that is x cube. Then how many y's we have? 1, 2, 3, 4. Y to the power of 4. Here you have to count x. How many x we have? 3. X raised to the power of 3. And how many y's we have? 1, 2, 3. Y cube. And how many z's we have? Only one z is here. The last one we have, first you have to write the numbers. That's the standard way to write it. And then if you look at a, that is a cube. And if you look at b, it is b squared. And if you look at c, so c to the power of, and that's our answer. Okay, the last one. So here we have to evaluate x power 1 there. So x power 1 is simple, x. Y power 0, anything raised to the power of 0 is equivalent to 1, except 0, 0 to the power of 0 cannot be equivalent to 1. 2 and then y, we already know that y power 0 is equals to 1, so that's why 2, and then in the bracket we have to write 1 because y power 0 is what? 1. 2 ones are 2. Now 2y whole power is 0, 1. Anything to the power of 0 will give you answer as 1. And you have to make sure that 2y0 cannot be equivalent to the whole 2y0, like the whole bracket and there's power 0. You have to always follow the bit mass rule there. So first we always have to do the brackets, then we do indices. Now in this one, division and multiplication, they both are equal. Like it is up to you, you can divide the number first and then multiply, or you can multiply the number first and then divide. And then we have addition and subtraction, they are also equal. You can also subtract the number first and then do addition, or you can do addition first and then subtraction. So that's it for this particular video. Thanks for watching. We will continue from the next.